This is the final exam review for pages 3, 4, and 5. So on page 3, we're starting with number 10. We're asked to write each polynomial in standard form and then classify it. So to classify it correctly, it has to be in standard form. So highest degree to lowest degree. So 7m to the 4th plus 4m squared minus m is now in standard form. And then we classify it by highest degree and number of terms. So this would be considered a quartic, or quarts in a gallon, quartic, and then trinomial. And the next one, highest degree first, so 3t cubed, and then 4t plus 2t's is 6t's, and then minus 7. We name it by the highest degree and number of terms, so this is a cubic trinomial. Hello.
Hello.
And then in this next one, our 2r squared goes first, and then plus 5r plus 7. And once again, highest degree, number of terms. So this one is a quadratic and trinomial. All right, so number 11, it says simplify. Simply simplify each expression. So you've got to kind of look and see what you're looking at here. So please excuse my dear Aunt Sally. You've got to multiply things first before you add or subtract them. So we have these two things being multiplied, and then we'll add it to this. So I'm going to focus on this multiplication first. X squared plus 5x plus 4x plus 20 plus 20. Combine like terms, so we have x squared plus 9x plus 20. And then we're simply adding that. Because of the addition sign, we're adding all this stuff. So plus 7x squared minus 8 minus 11. And since it's addition, we don't have to worry about changing any signs. Combine like terms. X squared plus 7x squared is 8x squared. 9x minus 8x is positive 1x. So plus x. Positive 20 minus 11. And my whole polynomial is off because if I look back, I wrote down the problem wrong. This was x minus 5, so we've got to change some things here. So redistributing, we have x squared, sorry about that, minus 5x. And then we have plus 4x, and then minus 20. So then we would have combined like terms. We had x squared minus 1x, and then minus 20. And then we would have added this 7x squared minus 8x minus 11. So once again, starting from here, we have 1x plus 1x squared plus 7x squared is 8x squared. Negative 1x's minus 8x's is minus 9x's. And then we have negative 20 minus 11, which is minus 31. So I just wrote down the original problem wrong, and this would be our final answer. Okay, on the next one, once again, you've got to take care of. Please excuse my dear Aunt Sally first. So parentheses. Well, if there's anything inside your parentheses to simplify, you can. And then multiplication comes next. So I have these two things being multiplied. So I'm going to distribute that through. That's 3x cubed. And then plus 5x squared. And then minus x. And then we have minus 9x squared. And then we have minus 15x's. And then we have plus 3, combined like terms. So we have 3x cubed, and then it looks like negative 4x squared. And then we have negative 16x's, and then plus 3. And now we've got to be careful because we're subtracting all this stuff. So remember with subtraction, you've actually got to rewrite that negative 1, distribute that through. So I'm going to change colors here. Negative 1 times negative 2x cubed is positive 2x cubed. Negative 1 times positive 6x squared is negative 6x squared. And then negative 1 times negative 5 is positive 5. So because we've distributed that negative through, we can then drop those straight down. So we have plus 2x cubed minus 6x squared plus 5. And then we'll combine like terms. So highest degree, we have 3x cubed plus 2x cubed, which is 5x cubed. We have negative 4x squared minus 6x squared, which is minus 10x squared. Then we have negative 16x, nothing else there. And then we have positive 3 plus positive 5, which is positive 8. So that would be our final answer for this one. so we're asked to divide this using synthetic division. So remember, with synthetic division, you'll set this linear factor equal to 0 and solve. So x is equal to 1. That's what we're using in our box is the root. And then you write down your coefficients. So we have a 1, a 3, a negative 1, and a negative 3. The most important thing is to distribute your signs through when writing that. So this was negative 1, negative 3. So we drop that straight down, multiply it back up. It's 1, so you put it right here. Add straight down is 4. 4 times 1 is 4. Add straight down is 3. 3 times 1 is 3. Add straight down is 0. That's our remainder. This must be our constant, x squared. So when we divided it, we got x squared plus 4x plus 3, and that was our final answer with no remainder. All right, and then on this one it says divide using synthetic division. Once again, we'll use x is equal to 4 because we always use our root. So 4, we set up our coefficient. So we have a 2, a negative 3, a negative 18, and a negative 8. Then we draw our line, drop this 2 straight down. 2 times 4 is 8. Adding straight down is 5. 5 times 4 is 20. Adding straight down, we get a 2. 2 times 4 is 8. Adding straight down, we get a 0. That's our remainder, our constant, our x squared. So our answer, when we divided that, was 2x squared plus 5x plus 2. And we have no remainder, and there's our answer. On number 13, it says find all the imaginary solutions. We already did the first one together using our u substitution. So I'm just going to start with x cubed minus 6x is equal to 0. So first of all, in this term and in this term, there's an x in common. I'm going to factor out an x. When you factor out an x, you divided each term by x. That left us with x squared minus 16. The whole point of factoring is so you can set each of your factors equal to 0. So we have x is equal to 0, x squared minus 16 is equal to 0. Solve for x in each case. This one's done. We're going to add 16. X squared is equal to 16. Square root both sides. So x is equal to plus and minus 4. And there's 3 answers. There better be 3 because it was degree 3. So we've done this correctly. On this next one here, we have 6x cubed minus 2x squared plus 4x. The first thing I notice is there is a 2x in common, so I'm going to factor out 2x. Divide each thing by what you pulled out very carefully. We have 3x minus 1x, and then plus 2. So then from there, the whole point of factoring is so we can set each of those equal to 0. So we say 2x is equal to 0, and we say 3, and that was 3x squared. So we have 3x squared minus x plus 2 is also equal to 0. So we set also this equal to 0. So then from there, we'll solve each case, divide by 2. So x is equal to 0. There's one of our answers. And here, to solve it, it's a quadratic. So I'm going to use the quadratic formula. X equals negative b. Well, a is equal to 3, b is equal to negative 1, and c is equal to 2. So x equals opposite of b. So positive 1 plus or minus the square root. You've got to put that in parentheses. Minus, so b squared minus 4 times a times c. And that's all over 2 times a. So we have 1 plus or minus the square root. If you type that incorrectly, you're going to get negative 23 underneath. And that's all over 6. So simplifying that all the way, this would become 1 plus or minus I square roots of 23 all over 6. And there's 2 more answers. So we have 1, 2, 3, which makes sense. It was degree 3, so we better have 3 answers. On number 14, it says, what is p of negative 4, given that this is our function? So we can do this a couple different ways. It wants to know what's our remainder. So we can just simply plug in negative 4 wherever there's an x. So we'll have p of negative 4 is equal to 2 times negative 4 to the 4th minus 3 times negative 4 cubed plus 5 times negative 4 squared minus 1. Calculate that in your calculator and you get 783. You've got to use parentheses. Now also, if you would have done synthetic division using negative 4, you would have set up your box with negative 4, 2, negative 3, 5, and negative 1, and you would have gone through the process and you would have got the same thing. Our remainder would have been 783, so that would be p of negative 4. All right, on the next one it says, number 15, write a polynomial function that has these zeros. So our zeros are -3 and 2. Those are our x values. Zeros are x values. So x is equal to -3, x is equal to 2. Now, if we're going to go backwards, we've got to add 3. We've got to get this set equal to 0. So we have x plus 3 is equal to 0, minus 2. X minus 2 is equal to 0. And because they're both equal to 0, we can pull them together and multiply them out here. So then from there, we'll distribute. We'll have x squared minus 2x plus 3x minus 6. Combine like terms, we'll have x squared plus 1x and minus 6. And so we would write our final answer as x squared plus x minus 6. And this would be our final answer here. That is the polynomial with these zeros. Okay, so it says the product of three numbers is 90. Okay, interesting. The second number is twice the first. The third number is 2 more than the first. So we don't know what the first number is, so let's call it x. Now the second number is twice the first, so 2 times the first. That's twice the first. And then the third number is 2 more than the first. So our first number plus 2 more. So these are our three numbers. And it says the product, so that means when you multiply these things, we get it's equal to 90. So what we really have then is 2x squared times x plus 2 is equal to 90. So what we really have is 2x cubed and then plus 4x squared is equal to 90. We can solve this a couple different ways. How I did it was I graphed it in my graphing calculator. So I'm actually going to pull up my graphing calculator here. So we want to know when is 2x cubed plus 4x squared, when is this function equal to this function right here is equal to 90. When do those two things intersect? So we know this is a cubic function and this is a line at y is equal to 90. So we just have a straight line. When are these two things equal? That's going to be where they intersect. So let's pull up our calculator and graph it and then find the intersection point of those two functions. So I'm going to y equals, my first function was 2x, let's move this out of the way. It was 2x cubed, and then it was plus, let's see, where is it? So it was 2x cubed plus 4x squared. Okay, sorry, plus 4x squared. And that's our first function, and we want to know when that's equal to 90. So we have a straight line at 90. That's our y2. Now think about it. If we have a straight line up at 90 on our y-axis, we need to at least see in our window on the y max up to 90, at least. In fact, I'm going to make it even greater than 90 because I want to see above that. So our y max is at 20, so if we don't change this, we won't be able to see that straight line and we won't be able to see their intersection points. So I'm going to say I want to see up as high as 100, so I change my y max to 100, I hit graph. Alright, let's see what this looks like. So it's graphing the cubic, there's my cubic equation, and there is my straight line at 90. So what x value do those two things equal each other? Where do they intersect? So I do second trace, and then go down to intersect. So they're intersecting at, so our first curve is on the cubic equation. I hit enter. My second curve, it's on the y equals 90. It's on the straight line. I hit enter again. It says, do you want me to guess? I hit enter again. So if we were to solve this, it intersects at x is equal to 3. So obviously our y value is 99. It's going to be as high up as 99 since that's where that line is. But our x value is 3. So it intersects at x is equal to 3. So if we would have solved this by hand, we would have also got x is equal to 3. All right, so that is good. X is equal to 3, so that's one of our answers. But if the first number is 3, then our second number is twice 3, which would be 2 times 3, which would be 6. So our second number is 6. And then our third number is 2 more than that 3. So that would be 3 plus 2, which is 5. Now look, it makes sense. Even do it in your calculator. 3 times 6 times 5 equals 90. So we found those three numbers. The answer is 3, 6, and 5. Okay, on this one, on number 17, it says the volume of a box is equal to this. So this is our volume. Now we know volume is equal to length times width times height of a square or cube. So it says, number 17, the volume of a box is x cubed plus 4x squared plus 4x. Explain how you know it is not a cube. Well, if it was a cube, then wouldn't all the dimensions be the same? If we have a true cube, then every piece of it is equal. So our length would be the same as our height, the same as our width. So really, we would have a cube if the length times the width times the height, if those factors were all the same. Well, the only way to tell the factors is to actually factor it. So I'm going to look at that piece and factor it. So the first thing I see in common is x. So I pull out x, divide each thing by x. Left is x squared plus 4x, and then plus 4. So then I can factor this piece further. It's quadratic, so I'm doing what multiplies to be 4, adds up to be 4. 2 times 2, so 2 plus 2. And a quick factor, since our a value is 1, so it factors to be x plus 2 times x plus 2. So the volume is x times x plus 2 times x plus 2. So we know that this volume, that's just the factored form of this. It's the same thing. This is just the factored form. Well, look at your factors. Are they all equal? No. Look, our length and our width were the same, but our height is not the same. If it's a cube, then they would all be exactly the same. So with this one, we know it's not because all the factors are not exactly the same. So that's why it's not a cube. If it was, either we would have had x plus 2, we would have had x plus 2 times x plus 2 times x plus 2. But it's not because of that x. So we'd say because of x, it doesn't have the exact same factors. Same three factors. Okay, number 18 says, what's the error? Your friend says that for this polynomial, the end behavior is down and up. Well, take your calculator, graph it, and what do you see? Well, it's definitely not down and up. But also, we could use this fact. If it's an even degree, it has the same end behavior. So we know it has same end behavior, meaning it's either going to be up and up or down and down. Then the next thing you look at, is it positive or negative in the front? Well, positive 1/3, so it's positive, like a positive person. So it's positive, so we know that the end behavior, so end behavior is up and up. If you don't believe me, use your calculator. Look at it. Is the end behavior up and up? Yes, it is. Okay, so we're asked to expand these things. I'm not going to take a whole lot of time to do it, but we had to rewrite this as 2a minus 1, 2a minus 1, 2a minus 1, 2a minus 1, 4 times. I multiply those two together, combine like terms, multiply those two together, combine like terms. And if you do that, you should be multiplying 4a squared minus 4a plus 1 times 4a squared minus 4a plus 1. You'd very carefully distribute. We distribute, and then we distribute again. And then we distribute a third time here. And then we combine all like terms. And if you do that, you would get this answer. You should practice it. Don't just write down my answer, because it all comes down to, can you do it? Okay, so the final answer here is 16a to the fourth. 16a to the fourth minus 32a cubed plus 24a squared minus 8a plus 1. And that would be our final answer here. Alright, on this next one, you'll do the same thing. X plus 3, x plus 3, x plus 3, x plus 3, x plus 3. And I multiply those two together, I multiply those two together, then I would multiply this with this, and then my last step would be to multiply whatever that is with x plus 3, and if you do that, which I would definitely practice it first by myself, you will get x to the 5th plus 15x to the 4th plus 90x squared plus 270x squared plus 405x and then plus 243. So that would be our final answer. Now there's actually an easier way to do this, kind of easier. We haven't learned it yet. So you can always go back to the good old math that we've always known. There are right ways and there are long ways. This is kind of the long way, but we just haven't learned the other thing yet, so that's the only way we know how to do it, so we'll do it that way. Okay, on number 20 it says, use the rational root theorem, and this is, holy cow, what you guys struggled with on that test. Use the rational root theorem to list all possible rational roots, and then state the actual rational roots. This is our Q. Q comes first. This is our P. List all the possible factors of P. Plus or minus 1, plus or minus 2, plus or minus 4. Those things all multiply to be 4. Every possibility. Factors of 1, plus or minus 1. Now you take all possible P divided by Q's. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. So these are the possible rational zeros. Now to find the actual, so this is part of our answer, you have to be able to list the possible rational zeros. Then from there, to find the actual rational zeros, you'll graph it in your graphing calculator. If you do, it looks something like this. You'll find the 0. Now don't just watch the video and not practice this, because you did that on the test and you got them wrong. Left bound, right bound. This is at x is equal to negative 4. So our actual rational zero is negative 4. So that's just a small piece of the answer there. So same thing with this next one. This is our Q comes first. This is our P. List out all the factors of P. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and don't forget plus or minus 18. And then Q is plus or minus 1, plus or minus 2. All possible P divided by Q's. 1 divided by 1 is 1. 1 divided by 2 is 1/2. 2 divided by 1 is 2. 2 divided by 2 is 1. We've already listed 1. 3 divided by 1 is 3. And 3 divided by 2 is 3/2. And we keep doing this. 6 divided by 1 is 6. And then 6 divided by 2 is 3. We've already listed 3. 9 divided by 1 is 9. 9 divided by 2 is 9/2. And then 18 divided by 1 is 18. And then 18 divided by 2 is 9, which we've already listed. So these are the possible rational zeros. So that's a piece of the answer. You've got to be able to list all possibilities. So then from there, you've got to graph it in your graphing calculator, do second trace, find which actual rational zeros are roots. So you graph it in your graphing calculator, and it looks, once again, something like this. So you'll do second trace, left bound, right bound. And if you do that, you get x is equal to 0.5. So we know that that's 1/2. If you didn't know, you would start testing these. What's 9 divided by 2? What's 1 divided by 2? What's 3 divided by 2? Which one matches up with this? So since 0.5 is equal to positive 1/2, our actual zero is positive 1/2. So that's a small piece of the final answer here. Okay. So on 21, we're asked to find the complex roots. Complex roots are just not imaginary roots, and they're not irrational roots. So fractions and whole numbers. So I just use my graphing calculator. I graph it, so I do my graphing calculator, I type it in, and I get something that looks like this. And I find the two zeros that can be written as a fraction. So I do second trace, I do left bound, right bound, and for each of these I get x is equal to negative 2, and I get x is equal to 2. So my two complex roots are 2 and negative 2. Now we could go through and find the other two roots if we wanted, but this is where we could stop for complex roots, because these are the roots that are numbers, whole numbers, or fractions. So they're not imaginary, not irrational. That's just what complex root means. Not imaginary, not irrational. So you do have to be careful with something like this, because what if you would have got x is equal to, if you would have got x is equal to 0.666667. If you were to say that that's not a complex zero, you're wrong, because that actually is 2/3. So how would you know if 0.66667 is a complex zero? You would refer back to your rational root theorem. So you would say, okay, I'm going to look at my p over q's, and is 0.6667 a root? And 0.6667 is actually 2/3. So that's why, you know, you have to be careful. Just because it's a decimal doesn't mean it's not a complex root. If it's a decimal, is it a decimal that can be written as a fraction? And if so, then it's a complex root. So just be careful. On 21, so I graph it once again on my graphing calculator. And I get something that looks like this. So looks like this. I do second trace, I find the 0, and it looks like it's at -3. And that's the only place it crosses. That's the only whole number root. So x is equal to -3. So that's the complex root. We could find the other two roots, but they're either irrational or imaginary. Because if they were rational, meaning can be written as a fraction, they would definitely cross the x-axis. So our complex root is -3. Okay, number 22. We're asked, okay, from the parent function y equals x cubed. Remember, parent function means non-shifted function. It hasn't moved anywhere. Well, that looks like this. So our parent function is non-shifted function. So if you graph that in your graphing calculator, you'd see it looks something like this. And now we've shifted it. So we have a shifted function, and it wants to know where did we shift it from our parent function. So remember, you always look where did we move left and right? Where did we move up and down? Inside the parentheses with x is your shift left and right, and we always go opposite. So this will be shifted left 4. And then there's nothing added on the outside. Anything added to the outside would be your shift up and down. So there's no shift up and down. So we only shifted left 4. But then also, we also have this acceleration that has been changed. Our acceleration is 1/6. So what that means is we went left 4, back 1, 2, 3, 4, and then we didn't shift up and down at all, but our acceleration is 1/6. So if you remember how a cubic function works, you go up your a value over 1, up your a value over 3. So we're going to be, our a value is 1/6. So we'll be going up 1/6 over 1, up 1/6 over 3, and then up 1/6. Oh, just a second. Sorry, that is a cube root. I'm sorry. I messed that one up. Let me erase that. So our acceleration is 1/6. So we're actually going to be going, it's going to be a stretch of 1/6. So we're going to be going, you always go left or right, it's the 1, 3, 5 rule. Hold on just a second. Let me just show you my graphing calculator. I'm confusing myself here. So let's graph this 1/6 times x plus 4 cubed. So I type it into my calculator and I hit graph. And then I could also graph, so if we hit graph, we'll see what our cubic function looks like. So it's been shifted left 4, and then it's kind of really stretching it out. So because of that 1/6, it's stretching it out. It's like opening it wider. So the acceleration is less. So that's why. So our acceleration is 1/6, so it's not growing so fast. Our acceleration is, instead of being 1, it's being cut into a 6. Because when our acceleration is 1, we always go over 1, over 1, up 3, over 1, up 5, and we do that on both ends, just like we would a parabola. But now we're going over a 6 up 1, over a 6 times 3, over a 6 up, you know what I mean? So it's just, we've got to be really careful here. So it's stretching it out, and also I'm going to graph the parent function just so you can see how different they look. The parent function was simply x cubed. So x cubed. So if you hit graph, look at it. So see how it's graphing this? See how the acceleration is much greater on the parent function? It's like zooming up there way quick. So that 1/6 stretched us out. It's like, whoo, and all of a sudden kind of chubby, and it shifted this from the parent function, it shifted it back 4. So what we would say is, so we know it kind of looks like that. It's really stretched out. So what we would say is it's left, it's a shift left 4, and then our acceleration became a stretch. So our acceleration was stretched by 6, stretched by 1/6. I really hope I didn't confuse you too much on that. All right, moving on. So number 23, it says, what's the polynomial function whose graph passes through each set of points? How many points do we have? 1, 2, 3, 4 points. So the n plus 1 point principle says we always do one less than that. So this is going to be degree 3. You'll type it into your calculator in list 1. You type in your x values in list 2. You type in your y values. Then you'll do stat calculate, and then we'll do cubic regression line, and it comes out as 6x cubed plus 2x squared minus x plus 3. And that's the only one I'm going to do for that one because we just tested on that. That second one you should be able to do pretty quickly. All right, so this one was a little bit harder. It says, given the potential energy of a spring varies directly as the square of the stretch length L. The formula is PE, which stands for potential energy, is equal to 1/2 times K times L squared, where K is the spring constant, and where when you stretch the string, and where L is the length. Okay, so it says, when you stretch a spring to 12 feet, it has 483 foot-pounds of potential energy. So what's the spring constant for this spring? So the spring constant is K. So in this first part here, we're going to be solving for K. So we're going to plug in what we know. You stretch a spring 12 feet and it has 483 pounds of potential energy. So potential energy was 483. That's equal to 1/2. We're trying to find K. We're trying to find the spring constant. And our length was 12 feet. So 12 squared. So then from there, we just got to isolate K. Got to get it alone. So we have 483 is equal to 1/2 times K times 144. So now to get K alone, I'm going to, first of all, divide both sides by 1/2. So if you take 483 and divide it by 1/2, 483 divided by 1/2 is 966. And if you don't believe me, type it into your calculator, but that makes sense. A lot of people are like, well, how is that true? 483 divided by 1/2, but it's not like dividing it by 1/2. When you divide fractions, it's easy as pie. You flip the second fraction and multiply. So we're technically taking 483 and we're multiplying it by 2, which is 966. And that's equal to 144K. So left on this side was 144 in K. So divide both sides by 144. So our K was equal to 161 over 24. I chose to go for the fraction rather than decimal. So now that we found the spring constant, what's the potential energy? So now we're answering the second question. What's the potential energy when stretched to 7 feet? So now we're using that same formula, PE, but that's what we're solving for, is equal to 1/2 times the spring constant, which we just found, 161 over 24, and then times by 7 feet. So our stretch, our L, our length is 7, so 7 squared. You'll literally type that into your calculator, and if you do, you get 164.35, and our answers are in foot-pounds. Foot-pounds. So this would be our final answer for that one. So we first had to go through and find K, so that we could then find the potential energy when it was stretched to 7 feet. Okay, so 25, it says given the area is equal to 2r squared plus r minus 1 of a box, and our length is 2r minus 1, what's the width? So we know area is equal to length times width. So 2r squared plus r minus 1 is equal to the length, which is 2r minus 1 times by our width. So there's a couple different ways we can do this one. I just said, okay, well, you could factor this piece. That's probably as easy as anything, and then see what two things multiplied to be the area. So that's just as easy as anything. I'll just do that. 2 times negative 1, what multiplies to be negative 2, and adds up to be 1. 1 times 2, negatives with the 1. Then we have to long factor, so we drop down our n terms, 2r squared, we drop down negative 1, and we rewrite it as negative 1r plus 2r. And then we group the first 2 terms, group the second 2 terms, and factor out an r out of that. Left is 2r minus 1. We factor a 1 out of that. Left is 2r minus 1. Our safe haven's good, so we factor out 2r minus 1, and then it divides out, so left is r plus 1. That's one way of doing it. So if this is our length, then our width must be r plus 1. So we'd say our width is equal to r plus 1. That's one way of doing it. Or another way of doing it is to say, okay, well, I know how to divide polynomials now that I have learned that from Miss Christensen. So we could also do it that way. We could say, okay, so now to solve for width, I divide both sides by 2r minus 1. Divide by 2r minus 1. So on top I have 2r squared plus r minus 1. On bottom we have 2r minus 1. That's equal to the width. And then we could either factor the top, divide out common factors, or we could do synthetic division. You would set this equal to 0 and solve for your answer. So we'd have 1/2, and then we would set up our synthetic division. So 2, 1, negative 1. We'd go through synthetic division, drop that down. 2 times 1/2 is 1, add straight down is 2. 2 times 1/2 is 1, add straight down 0. So if this is our remainder, then this is our constant. If that's our constant, that's our x. So we would have 2x plus 2. And then in common in this was a 2. So we factor out a 2, left is x plus 1. So we would have known our width was x plus 1. So there were a couple different ways. But something's weird with this one because I'm like trying to figure out where this extra 2 went when I factored it. So I'm going to try this again. What multiplies to be negative 2, add the 2, 1. 1 times 2. This is negative, so we had 2r squared. And then we had minus r plus 2r minus 1. Group the first 2, group the second 2. There's an r in common. Left was 2r minus 1. Factor out a 1. Left is 2r minus 1. So then we factor out 2r minus 1. And left was r plus 1. Okay, so 2r minus 1 is our factor, then our length, and that's our width. I'm trying to figure out what happened with this extra 2. I'm going to have to think about that one and get back to you, because I did it 2 different ways, and then here I'm ending up with an extra 2 for some reason. That one is a good question. If you know what I'm missing here, then you feel free to grab me, because we should end up with the same thing. No matter how we do it, we should end up with the same answer. So, that can't be right. Something is wrong somewhere. So I'm going to go with r plus 1 for now, and I'm going to think on this one and get back to you. Bugging me. Okay. So with this next one, we're going to add and then simplify, if possible. So to be able to add fractions, you have to have a common denominator. These ones are common. So 3 plus 5 all over 2a is 8 over 2a. Now these are all things just being multiplied. So 8 divides by 2 and becomes 4. 2 divides by 2 and becomes 1. So we have 4 over a. And with this one, we didn't have to restrict our domain because it would specify if so. All right, so that's 26. On this next one, to be able to add or subtract fractions, you have to have a common denominator. To know a common denominator, we have to factor. So I'm going to factor that. If you factor it, it becomes x minus 1 times x plus 1. Make sure you push pause, factor it yourself. If you go off of just taking my word for it, you didn't practice it. That factors to be x minus 2 times x plus 1. And then we're subtracting x minus 1 over x minus 2. So the first thing is get a common denominator. This one has an x minus 2, it has an x plus 1. This one has an x minus 2. It needs an x plus 1. So I'm going to multiply the top and bottom by x plus 1. So on top I have x times x, which is x squared, x times 1, which is 1x, and then negative 1 times x is negative 1x, and negative 1 times 1 is negative 1. So just in this piece, I have x squared minus 1. And then in this piece, I have x squared, and then I have, so x times x is x squared, and then x times 1 is 1x, negative 1 times x is negative x, negative 1x, and then negative 1 times positive 1 is negative 1. So just in this piece, I have x squared minus 1. So on top, we have this piece had x squared minus 1, and then we're subtracting x squared minus 1. So x squared minus 1, subtract x squared minus 1, and if you do that, you've got to subtract all of this, so you've got to put that in parentheses. So really, we have negative x squared plus 1. So we have x squared minus 1 minus x squared plus 1 on top. And on bottom, we have our common denominator of x minus 2 times x plus 1. Combine like terms, and look, we get a 0 on top. So 0 times x minus 2 times x plus 1. Well, 0 divided by anything is just 0. So that's our answer. All right, on this next one, it says simplify and state excluded values. So the first thing we do is factor the top, factor the bottom. So on top, I do what multiplies to be, it's quadratic, and there's nothing in common, so I do what multiplies to be a times c, which is 12, and adds up to be 13. 12 times 1, 12 plus 1, and then we long factor. Now you would do this without just copying what I'm putting. The top factors to become 3b plus 1 times b plus 4, and on bottom we have a b plus 4. Before you divide anything out, you have to restrict your domain. So we would set anything in the bottom with a variable equal to 0, and we'd solve. So b cannot equal negative 4. So we have this, this is our answer. We can now divide. Those two things are exact factors. They divide out, so we have 3b plus 1 as long as b does not equal negative 4. On this next one, I'm going to rewrite this top in standard form, negative 2x plus 6. And on bottom we have 2x minus 6. Don't just say those divide out. They're very different, actually. But on top, if we have a negative in front, we factor out the negative. So I'm going to factor out a negative, and there's a 2 in common. So I'm going to factor out negative 2. Left is x plus 3. And x minus 3, right? If we factored out a negative 2, divide each thing by negative 2, we would get x minus 3. And on bottom, we factor out a 2. Left is x minus 3. Before you divide anything out, you'll restrict your domain. This is the only place where there's a variable, so x minus 3 is equal to 0, so x cannot equal 3. Now we can divide out factors. We have an x minus 3 on top, on bottom they become a 1. Negative 2 divided by 2 is negative 1, so our answer is negative 1 as long as x does not equal 3. Okay, when we multiply these things, we can just divide out common factors. So the first step is to factor it all. So I'm going to factor that top. If you factor it correctly, and you should be pushing pause on the video and making sure you know how to factor this, because you can always copy down what I'm putting. That's not going to help you for the final. And then this piece factors to be x minus 4. If you don't know how to do it, you better push pause and figure it out. And then this factors to be 2, and left is x plus 3. And now we can divide out exact factors. It doesn't say to exclude exclude values, so we just can start dividing things out. On top, on bottom, we have an x minus 3. We have an x minus 4, x minus 4, and then that's all that divides out. So on top, there was an x plus 5 left, there was an x plus 4 left, and on bottom, there was a 2. Same thing here, we're going to factor each piece, but dividing fractions is easy as pie. You flip the second fraction and multiply. So I'm going to factor just this piece. I pull out a 4x, left is x minus 3. On bottom I have x squared, nothing connected to it, so I'm going to write it as x and x. And then we're going to flip these and then multiply. So we multiply, we factor out a 3, left is x minus 3. So I factored that piece, and I put it on top because we flipped the second and multiplied. We have 8x. Now remember, only things that are being multiplied can be divided out. We have 4x on top. It is being multiplied, 4 times x minus 3. So 4 becomes a 1, and it becomes a 2. X and x become 1. And then on top, we have an x minus 3. We don't have an x minus 3 on bottom. We have a 3 on top, nothing on bottom. We have an x minus 3 on top, nothing on bottom. So left was x minus 3 times x minus 3. And then we had that left, and our 3 left. And then on bottom we have a 2 and an x squared left. So the prettiest way to write this, just saying, is x minus 3 squared, and that's over 2x squared. So this would be our final answer here. That's the end of this video. Thank you for watching. I really hope that you guys got it. If you have any questions, please come to me and ask them. Ready to go for tomorrow. We're going to be doing other pages.